So, hello everyone. Today we are going to discuss a very important topic in magnetics design, which is magnetic designs for manufacturing. So, today we will discuss that why the design for manufacturing is important, which we called as a DFM. So, why do we need to do DFM? We need to do DFM to make sure that whatever the component we are designing, it has the reliability and robustness. So to increase the reliability, to reduce the cost, and to reduce the lead time. So to increase the reliability, we make sure that we adapt the design to use the proven and repeatable process. How do we reduce the cost by using the DFM, design for manufacturing? uh, we ensure that the design whatever we are doing, it is should be get manufactured using the automated process wherever possible, so that we can speed up the manufacturing and we can reduce the cost, and second is that reduce the scrap. How do we reduce the lead time? So it is like higher throughput using standard process, reduce rework and use standard component, so that we can reduce the lead times of the raw material. So what are the important aspects which we should consider during our DFM review, or when we are doing the design for manufacturing? So there are three important steps manufacturing process. Here it is on like winding, termination, and soldering, and this is regarding mostly high frequency components, which you can see in the pictures. It can be a transformers, it can be inductors, and all these components is having three important process, which is a winding, termination, and soldering. So during the winding, what are the important things we should consider? The consideration what we should take into account is the pin out, the layering, the drag backs. So all these 3 points we will discuss in details in the coming slides. So first is the pin out, wire crossing. So as you can see in the pictures that in one picture left side, the pin out is in crisscross way, and which create the mechanical and dielectric stress. The right side picture, it shows that the straight pin out. So this is really good, and this is the ideal pin assignment which we should use, so that it should not create any kind of stress on the pin out. The second is the wire drag. So wire drag is that how you take the wire from one side to other sides, and drag back can damage the winding by winding pressure or from subsequenting layer. Like you can see it here, we should use the tape, start the tape before drag back, so it use the higher lever. Then 90-degree drag backs increase the lever and may need extra tape as well. And the spiral drag back can cause core fit issue, as you can see here that the spiral drag backs is done and then the core is not fitting here and it is damaging this wire. So this is the very important point which we should take care in the winding. And third is the layering. So how we can improve the layering in our component? So as you can see, first on the left side, the wire gauge is chosen very high, and the winding is uneven, and the layering is not done proper. So this is impacting the performance and other parameters of the components. So what we need to do, that during the design we need to ensure that we take the correct gauge of wire to make sure that it get the right layering and without compromising on the DC resistance. So to solve this problem, here you can see the pictures on the right side. This use the bifilar winding or two winding wire to achieve the same DC resistance level but better layering. So this we should take care while we are designing, that when we are choosing the conductor size, we need to make sure that it fit properly with the number of turns whatever we have to wind, and it should not create uneven layer. And choose the pinout that promotes good layering. The same rail pinout for even number of layers, cross bobbin pinout for odd number of layers. The next important point is the termination. So how we should terminate the winding wires. So specify the wire and pin combination that can utilize the pull break termination if possible. Pin with sharp edge are more suitable for pull breaking, and automated winding requires the pull breaking. So for very heavy wire, throw holes bobbin may be required. Like you can see here, throw hole bobbins. If the wire is very heavy, so this wire need to pass through this, so that it has the right termination and it does not create other issue like coplanarity issue. So third important point is that we should avoid the heavy wire on the surface mount terminal, otherwise it will have coplanarity issue, height issue, and use parallel winding splits and extra terminal for high current winding if it is required. So this is how we should take care all this manufacturing parameters while designing the component to ensure that we get the robust part when we build it. Next important point is the soldering. So large single strand is more difficult to solder than multiple lighter strands. So large strand, it required more heat, more time, more insulation damage. So what we need to do that avoid using heavy or leads winding on the same bobbin rail with fine wire windings. Ideally, the winding on the same bobbin rail should be within 3 gauge. Sometimes it makes sense to use heavier wire than necessary for soldering. So that we need to take care, consider that what is required and what best can be done during the designing. And this may need two soldering operation if wire mismatch is unavoidable. So solder termination. So solder termination, what important things we need to take care. So you can see as it is shown visually here in the picture, the large wire wraps. This is where the parts will actually contact PCB. So this will have the coplanarity issue. The bobbin standoff. This surface should contact the PCB. So here you can see that the solder is more exposed and it will create the coplanarity issue. So large wire termination on TH parts can cause height issue. So those are the important points of DFM, the design for manufacturing, and the practice of considering the manufacturing process, best practices during the design stage. It will increase the reliability and it will reduce the cost and lead time. So thank you very much, and we will meet in the next video shortly. Thank you. And if you like this content, I request you guys to subscribe to my channel so that you can get the next video intimation directly on your email and you can go through with that. So thank you very much. Bye bye.